Hi, my name is Wijntjes, and this is my Lab 1 presentation on charge tapes. As an introduction, a transfer of charge can result when an object is touched, pulled, or rubbed. The purpose of this lab was to learn about the property of charge by observing the interactions between two objects with the same magnitude of excess charge. Two pieces of clear tape were created to have the same magnitude of excess charge to gain a general understanding about the magnitude of excess charge an object can have under normal conditions. The result of this lab was that the magnitude of charge on each piece of tape was calculated to be 1.3 e-8 coulombs. Some of the physics principles highlighted in this lab were that like charges repel, opposites attract, conservation of charge, charges cannot be created or destroyed, the total amount of charge in a system is fixed, the total charge on an object can be altered only by the transfer of charges to and from that object, electric force is equal to charge times electric field is equal to 1 over 4 pi epsilon times q charge over r magnitude squared times r hat, r being the distance from the source charge to the observation location. F gravitational was also used in this lab. F gravitational is equal to mass times 9.81 meters per second squared. The pen test was used to determine if the U-tape was positively or negatively charged. Two pieces of U-tape, 0.20 meters each, were first created by quickly pulling pieces of tape off a base tape attached to a smooth surface. The two U-tapes repelled each other due to their like charges, and one U-tape attracted a negatively charged pen, so I was able to determine that the U-tape was positively charged. I floated the two pieces of U-tape with the same magnitude of excess charge next to each other and observed a separation distance of 0.028 meters. The momentum of tape B did not change once it moved d distance away, implying tape B was in equilibrium and F net was equal to 0. To calculate electric force on tape B, the magnitude of gravitational force was first calculated. The electric force from A on B acted as an equal and opposite force to the gravitational force acting on tape B. Therefore, F grav equaled F electric. The calculated magnitude of charge on the tape was 1.3 e-8 coulombs. I got 1.3 e-8 coulombs by first getting F gravitational as 1.96 times 10 to the negative 3 newtons. I was then able to set that equal to QE field, the formula for the electric force on an object, and then was able to determine Q was equal to 1.3 e-8 coulombs. To the right is some of my glow script code that I used to create my computational model. Some of my additional calculations were that the number of excess electrons is equal to point charge value over electron elementary charge. That came out to be 8.12 e10 electrons. The number of atoms on the sticky surface of the tape was equal to tape length over A atom size. That was 2e9 atoms. The ratio of electrons to atoms on the sticky surface came out to be 40.6 electrons to the atoms on the sticky surface. Some of the assumptions for my computational model were that each U-tape has the same net charge, evenly distributed throughout the piece of tape. Each piece of U-tape was treated as a point charge, meaning all the charge was located at the center of the tape. One piece of clear tape was approximately 1 gram per meter. The mass of one piece of tape was calculated to be 2e-4 kilograms. To the right, you can see my computational model. F electric is symbolized by the orange arrow. The green arrow symbolizes F gravitational, and the red sphere symbolizes the floating tape. F electric and F gravitational are equal and opposite to each other, symbolizing that the tape was motionless. My observations and conclusions were that the computational model aligned with observations, as the direction of the computed electric force on the floating tape indicated repulsion. The electric force on the floating tape pointed opposite to the other piece of tape. If electrons had positive charges and protons had negative charges, then the observed charges would have had opposite signs. Everything would have been opposite, causing the model to be the same because everything was reversed. Handling the tape as little as possible was important, as the transfer of charge occurred whenever the tape came into contact with another object. It was important not to introduce other forces. The tape had to be remade if a notable amount of contact was made, as it no longer had an excess charge. The excess charge on the tape was transferred to the neutral object whenever this occurred. Thank you for listening.